7/9 times 4/25. Oh my. Times 5/21. Oh my. Times 3/4. We have 4 fractions we're multiplying together here. Let's cancel what we can. Otherwise, we'd have to do 7 times 4 is 28, times 5 is 140, times 3 is 420, I believe. All over 9 times 25 is 225, times 4 would be 900, times 21 would be big number. So big number over big number, we would have to reduce that. So we would like to cancel. I like seeing this 4 on the top and this 4 on the bottom. That's a pair. It reduces to 1/1. 7/21, that's 1/3. 7 divided by 7 is 1. 21 divided by 7 is 3. Hey, there's a 3 on the top that can go with that 3 on the bottom. 1 and 1. 5 on the top, 25 on the bottom, that's 1/5. 5 divided by 5 is 1. 25 divided by 5 is 5. So all of that just to get all ones on the top. 1 times 1 times 1 times 1. And on the bottom, we have 9 times 5 times 1 times 1. So we get an answer of 1/45. So those huge numbers we would have gotten if we just multiplied across and multiplied across the bottom. We would have had to reduce that all the way down to 1/45. Cancellation was very helpful here. I also want to point out, what if instead of that 3 with the new 3, what if instead, before we even got there, we did this 3 with this 9? 3/9 is 1/3. Well, we still get all ones on the top, and now on the bottom, 3 times 5 times 3, 3 times 3 gives us that 9. So no matter what order we cancel and which numbers we cancel with, as long as we're doing correct things, the only thing we can come up with is the correct answer. If you get anything else, either it's not reduced completely and it reduces to the correct answer, or you've done something wrong and you don't have the right answer. More practice. 1/12 times 4/5. By now, you should be well aware of the fact that we can go across the top. 1 times 4 is 4. Across the bottom, 12 times 5 will give you 60, and then you could reduce 4/60ths to 2/30ths and end up with the answer of 1/15. Or cancel. 4 and 12 can both be divided by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 4/12, 1/3. 1 times 1 is 1. 3 times 5, 15. Another one. 10/15 times 3/16. 3 and 15. 3/15 is 1/5. Divide both by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. We can do the 10 with either of these. 10 divided by, let's do 2. 10 divided by 2 is 5. 16 divided by 2 is 8. 5 and 5 cancel. We get 1 and 1. 1 times 1 is 1. 1 times 8 is 8. 1/8. 7/96. We're already just going to hope for like a 0 or a 1 or something we can cancel with. Times 8/77. Oh boy. That was a 9. It's not showing up clearly. I said it before in previous lectures. I really got to get to Walmart, get some new markers. 7/77. We can divide those by 7. 7 divided by 7 is 1. 77 divided by 7 is 11. 8/96. They're both even. Divide them by 2. 8 divided by 2 is 4. 96 divided by 2 is 48. I can divide by 2 again. 4 divided by 2 is 2. 48 divided by 2 is 24. I can divide by 2 again. 2 divided by 2 is 1. 24 divided by 2 is 12. What are we left with? We just have 1s on the top, so we're definitely done. 1 times 1. On the bottom, 12 times 11. And 12 times 11, 132. 1/132 would be the answer. Let's talk about rounding mixed numbers. Let's say we had 8 and 5/6. If we wanted to round this to the nearest whole number, we would just have to ask ourselves, is the fraction part greater than a half? So when we see the 5/6, we would have to ask ourselves, what's the halfway point for sixths? 6 divided by 2 is 3, so 3/6 would be half. Anything over that would therefore round up. So 8 and 5/6 to the nearest whole number would round up to 9. Meanwhile, something like 9 and 1/7, the halfway point for 7 would be between 3/7 and 4/7. 1/7 is definitely below that. So to the nearest whole number, 9 and 1/7 would round down to 9. What about when we have bigger numbers in the fraction part? We just need to pay closer attention to what the halfway point would be. If we had 18 and 17/24, what would be the halfway point of 24ths? Well, 12/24 is 1/2. We found equivalent fractions, or we're going to find equivalent fractions in just a little bit. We talked about what makes equivalent fractions, cross multiplying and getting the same answer. 12 times 2, 24 times 1. For now, we're just going to find the halfway point by dividing by 2. 17/24 is greater than 12/24, so it's greater than a half. It rounds up to 19. Let's go back into multiplication. Except this time, we're not going to see everything as a fraction. Let's say we had the number 25 times 1/5. What would we do here? Well, take a second. And I want you to think about what you would do. Just your initial thoughts. And if you said that you would multiply both of those numbers by 25, you would be wrong. At no point in this problem would you multiply 25 times 5. Why is that? Well, the first step when we have whole numbers in fraction problems is to express them as fractions. And any whole number is equal to itself over 1. And that's why the 25 would only multiply through the top, 25 times 1. And the bottom is just times 1. 1 times 5. That gives us 25 over 5, which reduces by straight division. 25 divided by 5 is 5, or we get 5 over 1 when we reduce, which is 5. And since we reduced, that means there was an opportunity for canceling that we even missed. 25 divided by 5 is 5. 5 divided by 5 is 1. And look at this. 5 times 1 over 1 times 1. That's 5 over 1, which is 5. So no matter how you're doing the multiplication, what's important is that the 25 is a top number and there is a 1 on the bottom. 25 means 25 over 1. Multiply like usual from there. Let's do another one like that. 11 twelves times 4. Well, that means 11 over 12 times 4 over 1. You can go across the top, 44, across the bottom, 12, but then you'd have to reduce 44 over 12 to get the answer. I'm going to cancel this 4 and this 12. 4 divided by 4 is 1. 12 divided by 4 is 3. 11 times 1 is 11. 3 times 1 is 3. So we get 11 thirds. We need to ask ourselves, can we leave it 11 thirds, or do we have to turn it into a mixed number? And when you get into homework problems, you might get the direction, simplify your answer, type a whole number, fraction, or mixed number. And if it says that a mixed number is an option, then that is what it wants instead of the improper fraction. So we divide 11 divided by 3. 3 goes into 11 3 times. We get a remainder of 2, which we write over 3. 3 2/3. Let's do another. 1 4/5 times 5 over 36. And now we have no idea what to do. In fact, the only thing we do know at this point is because there is a mixed number in the problem, that means that we need to turn our answer into a mixed number if necessary. So if we get an improper fraction, we need to change it into a mixed number because the mixed number is in the problem. If we get a regular proper fraction, then there's nothing to worry about. Proper fractions don't get changed into mixed numbers, only improper fractions. We absolutely cannot just multiply the fraction parts here. We can't do 1 and whatever 4/5 times 5/36 is. The rule for multiplying mixed numbers, and this is going to carry across to dividing mixed numbers as well. We'll have different rules for adding and subtracting. When we're multiplying and dividing and we have mixed numbers, we must change the mixed numbers into improper fractions before we do our work. It's the only way we're going to get the correct answer. 5 times 1 is 5 plus 4 makes this 9/5. So the problem is 9/5 times 5/36. We can cancel. 5 and 5 is 1 and 1. 9 and 36 is 1 and 4 because they both divide by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. 1 times 1 on top is 1. 1 times 4 on the bottom is 4. And hey, it's not even an improper fraction, so we don't have to worry about taking it back to a mixed number. 1 and 4/5 times 5/36 is 1/4. Let's do another one like this. Four fifths times 4 and 7/12. Again, you can't just multiply 4/5 times 7/12. You must, absolutely must, turn this into an improper fraction first. So 12 times 4 is what? 12 times 4 is 48 plus 7. 49, 50 plus another 5, that's 55/12. 55/12. This is why we did practice in the homework with turning mixed numbers into improper fractions and vice versa. This is 4/5 times 55/12. Thank goodness we have canceling. 5 and 55 can both be divided by 5. 5 divided by 5 is 1. 55 divided by 5 is 11. 4 and 12 can both be divided by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 4/12 is the same as 1/3. 1 times 11 is 11. 1 times 3 is 3. Can we put 11/3 as an answer? Absolutely not. Why? Because there's a mixed number in the problem. This improper fraction is not okay. We need to turn it into a mixed number. And even if we didn't notice that, there would be a direction probably that says whole number, fraction, or mixed number. And if mixed number is an option and you get an improper fraction, you have to change it. How do we change it? We divide. We're doing 11 divided by 3. 3 goes into 11 3 times. 3 times 3 is 9, remainder 2. 3 2/3. Next. You might be asking, why is it that he just randomly talked about rounding mixed numbers. That seemed weird. It seemed out of nowhere. Well, for this next problem, we're going to multiply two mixed numbers together. 3 1/4 times 2 1/5. We're going to find both an exact product and an estimated product. And when we find an estimated product, that means we're going to round each to the nearest whole number, like we did in the earlier examples, and then multiply those whole numbers together to get a ballpark figure. Here, for the estimated product, 3 1/4, 1/4 is less than a half, so that's about 3. 2 1/5, that's less than a half, so that's about 2. We would have an estimated answer of about 6. To do the exact, we have to do the full work. And remember, when we're multiplying and there's a mixed number involved, we have to change it to an improper fraction. 12 plus 1 makes 13 fourths. Ten and 1 makes 11 fifths. We're multiplying and nothing cancels. So we have to do 13 times 11 over 4 times 5, no simpler way. The bottom, 4 times 5 is 20, we notice. On the top, 13 times 11 is 143. 143 over 20. It doesn't reduce, but it's improper. We're doing a mixed number problem, so we have to get the mixed number. We have to divide. 143 divided by 20. 20 goes into 143 7 times. 7 times 20 is 140. We get a remainder of 3. That goes over 20. 7 3/20. Not 3 times 2 is 6. 1/4 times 1/5 is 1/20. It's not 6 1/20. Absolutely not. Never. You cannot multiply the whole numbers, multiply the fractions, and get the correct answer. The only correct answer is 7 3/20. So this shows that estimating is a helpful tool, but it's not foolproof. What was our estimated answer? Our estimated answer was 6. If I told you the estimated answer was 6 and you had 6 1/20 or 7 3/20, you'd probably think it's 6 1/20 because of the estimated answer, but it's not. The estimated answer is just going to help us if it's like really far off. If we've made a huge mistake, it'll be noticeable, but it shouldn't guide us to thinking 6 1/20 is correct, because we never just multiply the numbers and multiply the fractions. They always have to go through improper form. Let's do it again. We'll estimate, and then we'll find exact. With 7 2/3 times 6 1/8. Let's estimate. Now the homework problems are going to do the other way. They're going to have you do exact first, then estimate. I'm doing estimate first. 7 2/3. 2/3 is over a half. So this is about 8. 6 1/8. An eighth is less than a half. So that's about 6. We're getting an estimated answer of about 48. How do we do it? Same way we've been doing all of these. Improper fractions. 3 times 7 is 21 plus 2 makes 23/3. 8 times 6 is 48 plus 1 makes 49/8. And this is it. This is the one we've been afraid for. These numbers are big and nothing cancels. We have to multiply. 23 times 49. So 23 times 49. 9 times 3 is 27. Carry the 2. 9 times 2 is 18 plus 2 is 20. 4 times 3 is 12. Carry the 1. 4 times 2 is 8 plus 1 is 9. When we add, we get that 23 times 49 is 1,127 over 3 times 8 is 24. 1,127 over 24. We need to change back to a mixed number. We do that with division. 1127 divided by 24. Now you're seeing why we did so much work with division for the last test. We need it. 24 goes into 112. How many times? Well, that's about 25, which goes into 104 times, and 112 is about 100. So let's look at 24 times 4. Let's take a look at 24 times 5 and make sure that 5 doesn't fit in. 4 times 4 is 16. Carry the 1. So that's 96. Times 5 is 120. So 5 won't fit, but 4 does. 4 times 24 is 96. We subtract. 2 divided by 6 can't do it. We're borrowing. 0. 12 minus 6 is 6. 10 minus 9, 16. Bring down the 7. 24 times 5 was 120. That'll definitely fit in. What about 24 times 6? Will that fit in? 6 times 4 is 24. Carry the 2. 6 times 2 is 12. Plus 2, 144. That fits. Does 24 times 7 fit? 7 times 4 is 28. Carry the 2. 168. It just barely doesn't fit. 6 times 24 is 144. Subtract. That's 23. We have nothing else to bring down, so that's our remainder. 46 and 23/24 is the answer, not 42 and 1/12. 46 and 23/24. This time, the correct way is actually closer to the estimation. But it's not meant to see which answer is correct. It's meant to make sure that we're in the ballpark. And 46 and 23/24 is definitely in the ballpark of 48. Let's take a look at this one. 3 times 3 4/5. And no, it is not 9 4/5. This is 3/1 times 15 plus 4 makes 19/5. So on the top, we need 3 times 19. That's 57. On the bottom, 1 times 5 is 5. And then we divide. 57 divided by 5. 5 goes into 5 once. 5 goes into 7 once. With a remainder of 2. 11 2/5. Not 9 4/5. 11 2/5. Let's do another. Let's take a look at 1 1/5 times 6 2/3. Is the answer 6 2/15? No. We have to go improper fractions. 5 times 1 is 5, plus 1 makes 6/5. Times 3 times 6 is 18, plus 2 makes 20/3. I can cancel. 6 and 3, both divisible by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. 20 and 5, both divisible by 5. 20 divided by 5 is 4. 5 divided by 5 is 1. On the top, 2 times 4 is 8. On the bottom, 1 times 1 is 1. 8/1 is just 8. Anything over itself, or anything over 1 is itself. Let's take a look at 3/5 times 30 times 2/3. Man, wasn't it nice when that middle number was 0 and we can just say 0 and move on? Instead, we rewrite our whole numbers as fractions. We cancel what we can. 30 and 3, both divisible by 3. 30 divided by 3 is 10. 3 divided by 3 is 1. That gives us 3 times 10 times 2 over 5 times 1 times 1. 30 times 2 is 60/5, which not only can we can reduce with straightforward division. 5 goes into 6 once. 5 goes into 10 twice. 60/5. Just plain old 12. Why did I still have a reducing step? It means I probably missed something else that could be canceled. And sure enough, I did. You also could have canceled completely. The 10 that we got can reduce with the 5. 10 and 5 are both divisible by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And so we actually have 3 times 2 times 2 over all ones. 6 times 2 is 12/1, which is just 12. But any way you look at it, the answer is 12. What about one of these series of threes? That have a mixed number? 7 over 20 times 9 times 2 1/2. Well, that whole number is not going to be the only thing that we need to simplify, or I should say rewrite. 7 over 20 times the 9 is 9 over 1 times mixed number has to be written as an improper fraction. 2 times 2 is 4 plus 1 is 5 halves. We can cancel the 5 and the 20. Both are divisible by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. On the top, 7 times 9 times 1, that's just 7 times 9 is 63. On the bottom, 4 times 1 times 2, that's just 4 times 2 is 8. Can we do an answer of 63 over 8, though? No, because that mixed number is there. So we need the mixed number in the answer. 63 divided by 8. 8 goes into 63. Well, 8 times 8 is 64. That's too much. So 7. 7 times 8 is 56. We subtract, we get a remainder of 7. 7 7/8 would be the answer here. Okay. The homework's going to go on, give you even more of these, but what we're doing is not changing as we go. Whole numbers become themselves over 1, mixed numbers become improper fractions. If there's a 0 in the chain, the whole thing becomes 0. If we get an improper fraction at the end and there's a mixed number in the problem, or it suggests a mixed number can be the answer, we need to change it and not leave it as an improper fraction. And we're going to look at division. But before we can actually divide, we need to talk about something called the reciprocal of a fraction. And here's how we find the reciprocal of, say, 9/10. You ready? This is difficult. We flip it. Flip a fraction upside down and we get what is called the reciprocal. Something interesting about the reciprocal is that if we multiply a fraction by its reciprocal, notice if we were multiplying, everything would cancel. We'd be left with 1 over 1. A fraction times its reciprocal is just 1. So let's find the reciprocal of 1/7. Well, we flip it and then simplify. 7 over 1 is just 7. How about the reciprocal of the number 14? Well, remember, 14 is 14 over 1, and we flip it. 1/14. What would be the reciprocal of 10/9? That's absolutely correct, 9/10. So why are we talking about the reciprocal? Well, in order to divide two fractions, let's say we had A over B some random fraction, divided by C over D. We leave the first fraction as it is. We change division to multiplication, and we take the reciprocal of the second. We keep the first. We change division to multiplication, and then we flip the second. And if you want to say keep, flip, change, then you have the kernel to help you out. But dividing by a fraction is multiplying by the reciprocal. Division is just multiplication of an amended problem. Keep in mind, canceling is something that is exclusive to multiplication. So you never cancel a division problem until it appears as a multiplication problem. So we would not cancel 9 and 33 because they both divide by 3, because what we see is a division problem, not multiplication. How do we handle this? Keep the first. Flip the second. Change division to multiplication. And then it's just more of what we did in the first half of class. 33 and 11 are both divisible by 11. 33 divided by 11 is 3. 11 divided by 11 is 1. 9 times 3 is 27. 1 times 4 is 4. No need to change it to a mixed number. This would be 27 over 4. Let's do another. 5/6 divided by 1/7. Keep, flip, change division to multiplication. 5 times 7 is 35. 6 times 1 is 6. 35 over 6. See, once we learn this one new thing, we just add it on to what we already knew. 2/7 divided by 3/4. Keep, flip, change division to multiplication. Nothing cancels. 2 times 4 is 8. 7 times 3 is 21. 8 21sts. Do not cancel the 2 and the 4 because that's a division problem. No cancellation can happen until we have a multiplication problem. Next, let's take a look at 5/11 divided by 7/11. Keep, flip, change division to multiplication. The 11s cancel, 1 over 1. 5 times 1 is 5. 1 times 7 is 7. 5/7. Am I trying to trick you with this next one? Maybe. But you're not going to fall for it. You're smarter than that. 9/8 divided by 8/9. No, this is not 1 because we cannot cancel those 8s and we cannot cancel those 9s. Why can't we cancel them? That's right, because it's a division problem. We divide by keeping the first. changing division to multiplication and flipping the second. 9 times 9 is 81. 8 times 8 is 64. 81 over 64. Dare I say these are kind of fun. 5/9 divided by 5/3. Keep, change, flip. Once we have multiplication, we can cancel 5 over 5. That's 1 over 1. 3 over 9, that's 1/3. 3 divided by 3 is 1. 9 divided by 3 is 3. 1 times 1 is 1. 3 times 1 is 3. Another one. Why not? You asked nicely. 12/5 divided by 7/5. Keep, change, flip. 5 over 5 cancels. 1 over 1. 12 times 1 is 12. 1 times 7 is 7. 12/7. Let's get these a little more interesting, shall we? One-fourth divided by 11/6. Keep, change, flip. Some canceling. 6 and 4 can both be divided by 2. 3 and 2. 1 times 3 is 3. 2 times 11 is 22. 3 over 22. Okay, it was a little more exciting. What can I say? It's only division of fractions. The bar can only be set so high. 4/59 divided by 1/6. Keep, change, flip. Nothing cancels. 59 isn't divisible by 2 or 3 or 6. So multiply across the top. 4 times 6 is 24. On the bottom, 59 times 1 is 59. 24/59. Let's look at 4 over 33 divided by 20 over 143. Let's start, as always, with keep, change, flip. And these numbers are very large. We can start by canceling the 4 and the 20. Both are divisible by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. And at this point, I wouldn't blame you if you didn't think there was anything else to cancel. You would do 1 times 143 is whatever. 33 times 5 is whatever. And then you would need to start reducing. But let's take a look at the 143 and the 33, because they do have something in common. It's not going to be 3. 143 is not divisible by 3. because 1 plus 4 is 5 plus 3 is 8. The digits don't add up to a multiple of 3. But 33, what's the other obvious thing it's divisible by besides 3? 3 times what is 33? 11. 143 is actually 13 times 11. How did I recognize that? There's a divisibility test for 11. Anything times 11, you actually add the digits together. 1 times 3 is 4, and stick it in between. So 11 times 13, 1 plus 3 is 4. 11 times 13 is 143. So I recognize that's a 4 in between 1 and 3. That makes this divisible by 11. 143 divided by 11 is 13. 33 divided by 11 is 3. 1 times 13 is 13. 3 times 5 is 15. 13 fifteenths. Let's use this 11 trick again real quick. What's 15 times 11 going to be? 1 plus 5 is 6. 15 times 11 would be 165. What about 23 times 11? 2 plus 3 is 5. 253. What about 21 times 11? 2 plus 1 is 3. So that's a nifty little times 11 trick that helped us out here. Got us to 13 over 15 a little bit easier than reducing larger numbers. Speaking of 11, we got a lot of them in this problem. 10 elevenths divided by 10 elevenths. Well, I'm going to come back to the shortcut in a second, not the 11 shortcut. This is a completely different thing. But if we did this with keep, change, flip, the 10s cancel 1 over 1, the 11s cancel 1 over 1. Our answer is just 1. Anything divided by itself is 1. Remember, 5 over 5 is 1. Anything divided by itself, 10 elevenths divided by itself is still going to work out to 1. And that's because keep, change, flip. That'll give us a little bit more work. When we first did division, recall that 0 divided by anything was 0. 0 divided by anything is 0. If 0's on the top, we get 0. But anything divided by 0 or 0 on the bottom was undefined. So in this next example, when we have two ninths divided by 0, as soon as we see divided by 0, our answer is undefined. But the 0 coming first, 0 divided by, say, 15 sevenths, the 0 coming first is okay. It just means we have an answer of 0. Why? Keep, change, flip, 0 times anything is 0. When 0 comes second, we can't flip 0, so we can't do it. Okay, let's work on a larger problem. 16 1/105ths divided by 64 1/75ths. So how do we start? It won't be canceling because it's a division problem. But we turn division problems into multiplication. Keep. Change. Flip. The problem we're actually going to be working on is 16 1/105ths times 175 64ths. I'm going to work on canceling, and I'm going to use small numbers. I know I can do 4, but I'm going to just, they're both even. I'm going to break them down by 2. 16 and 64 broken down by 2 would be 8 over 32. Still even, cut them in half again, 4 over 16. Still even, cut them in half again, 2 over 8. Still even, cut them in half again, 1, 4. So it doesn't matter if you didn't realize that you could divide them both by 16, or that you can divide them both by 8, or you can divide them both by 4. You can just keep going by 2. There's no end to the number of times you're allowed to cancel. Let's do the same over here. 105 and 75, they both end in 5. So what are we going to divide by? 5. I'm going to need some help though. $175 divided by 5. Five goes into 17 3 times. 5 goes into 25 5 times. So 75 divided by 5 is 35. 175 divided by 5 is 35. I think I said that wrong. How about 105 divided by 5? If we do that, we're going to get 21. And then 21 and 35, we can divide them both by 7. 35 divided by 7 is 5. 21 divided by 7 is 3. So what do we have here? We have 1 times 5 is 5 over 3 times 4 is 12. 5/12. Palette cleanser. Those were big numbers. Let's bring it back to something a little more comfortable. 1/6 and divided by 5/3. Keep. Change division to multiplication. Flip the second fraction. We can cancel 3 and 6, both divisible by 3. 3 over 6 is 1 over 2. So 1/10. Let's go ahead. There'll be more practice with this in the homework. But let's go ahead and bring in dividing by whole numbers. 5/12 divided by 15. So remember, when we were doing our multiplication problems and we had a whole number pop up, we had to write it as itself over 1. We have to see it as a fraction before we can flip the fraction. Keep the 5/12, change division to multiplication, and flip the 15 over 1. 1/15. 5 and 15 can both be divided by 5. So 1/3. 1 times 1 is 1. 12 times 3, 36. So 1/36. What about if the whole number comes first? That's okay. If we have 6 divided by 7/10, we would rewrite 6 as 6 over 1. And then keep, change, flip. 60 over 7. And unless they give us an indication that we need a mixed number, since it's not containing a mixed number in the original problem, we do not need to divide that out and get a mixed number. But if the problem were to come with a mixed number, such as in the problem 1 1/13 divided by 1/13, if we were to get an improper fraction, we would have to change it to a mixed number. And just like multiplication, mixed number division problems need to go through improper fraction form. So when we see the mixed number, even before we change it to multiplication, we need to make this 13 times 1 is 13 plus 1 makes 14/13 times 13 over 1. The 13s cancel, 1 over 1. We get 14 over 1, which is 14. No fraction at all. So no need to worry about making it a mixed number. Well, maybe we'll have to change the next one to a mixed number. 17/21 divided by 1 6/7. Get rid of the mixed number. 17 over 21 divided by 7 times 1 is 7 plus 6 makes 13/7. Keep the first, change division to multiplication, flip the second. 17/21 times 7/13. 7 over 21, both divisible by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. On the top, 17 times 1 is 17. On the bottom, 3 times 13 is 39. It doesn't reduce, it's not improper, so we can't even make it a mixed number. 17 over 39. Let's do another. 5 1/5 divided by 7 and 4/5. 5 times 5 is 25, plus 1 is 26/5. Still divided by 5 times 7 is 35, plus 4, 39/5. And now we keep, change, flip. If I'm going too fast for your notes, pause me. 5 over 5 cancel to 1 over 1. We have 26 over 39. This is another one where I would not be surprised if you got to here and did not realize that it reduced. But it does reduce because, believe it or not, there was something else we could cancel. To reduce this, we would have to realize 26 is 2 times 13. 39 is 3 times 13. The 13s cancel, and we get 2/3. Up here, there they were, 13 times 2 and 13 times 3. Fully canceling would give us 2/3. So 11s, 12s, 13s, they might make things a little bit difficult. In the homework, if you would have put in 26 over 39, it would have given you a message something like, not incorrect, not that dreaded red incorrect. It'd be more like a yellow, and it might say, your answer is equivalent to the correct answer, but not in proper final form. And that's telling you, hey, all the work you've done so far is right. You just need to go further. Let's have another. 1 8/9 divided by 3 and 1/6. Mixed numbers to improper fractions. 9 times 1 is 9, plus 8 makes 17/9. Divided by 6 times 3 is 18, plus 1 makes 19/6. Keep, change, flip. 6 and 9 can both be divided by 3. 6/9 would be 2/3. Nothing else cancels, so we would go 17 times 2 is 34. And then 3 times 19 works out to 57. 34/57. Let's do another mixed number problem. See if you're paying attention. 0 divided by 16 and 4/5. Well, we have division involving 0. The 0 comes first and not second. So the answer is just 0. How about if we had 1 divided by 5/9? Well, just because anything divided by 1 is itself does not mean it works the other way. 1 divided by is something completely different. To see this, we would go keep, change, flip. What is 1 times 9/5? 1 times is itself. Our answer would be 9/5. Notice 1 divided by is not itself, it's the reciprocal. We did 1 divided by 5/9 and we got the reciprocal of 5/9. Is that going to work every time? Absolutely. If it was 1 divided by 3/8, keep, change, flip. So then it's 1 times the flip. It's just the reciprocal, 8/3. And if we had something like 2 2/5 divided by 0, the 0 comes second. This one is undefined. We wouldn't be able to flip 0 and get a real number. Let's take a look at 29 and 1/3. I'm sorry if you could hear that squeak, at least it's working. 29 and 1/3 divided by 1 4/7. So we've got to do improper fractions, unfortunately. 3 times 29 is 87, plus 1 makes 88/3. Divided by 7 times 1 is 7, plus 4 makes 11/7. Keep, 88/3. Change division to multiplication, flip, and we get 7/11. Cancel. 88 and 11, both divisible by 11. That would be 8/1. And why couldn't I finish class without showing an example like this, where we get 56/3? Because finally, not there. Finally, a problem with mixed number division where we got an answer that was an improper fraction. And that means we have to turn this improper fraction into a mixed number to match how the problem was given. So we divide 56 by 3. 56 divided by 3. 3 goes into 5 once. 3 goes into 26 8 times. And when we subtract 24, we get a remainder of 2 that we put over 3. 18 2/3 would be the answer here.